And notice, this is Mars, exactly about 4 billion years ago. So here's the problem. Where is the atmosphere of Mars? Was ancient Mars really like this? Billions of years ago, we know that there was liquid water on Mars, like the Earth. And this has been proven time and time again. Whether it is our view, observed signs of ancient river water rocks, or detect the vehicle found on the surface, minerals formed only in the presence of water, have confirmed this. This video, The Old Horse, is mixed with some personal discoveries. Let's discuss it with everyone. Where did the old Mars go? About 4 billion years ago, there are likely to be large areas of water on Mars. There might even be oceans. Concentrated in the low-lying northern hemisphere, there are lakes in the southern hemisphere. The mainstream scientific community acknowledges that. A description of the history of Mars, from orbiting satellites to landing probes. All signs are showing. Mars once had liquid water, but there is water on Mars. That creates a problem. Today's Mars lies outside the habitable zone. The temperature there is for liquid water. Temperature is too low. If you must give a reasonable explanation, that was Mars like Venus. It has a thick atmosphere. Make Mars warm enough to maintain liquid water. But 3-4 billion years ago, the sun should be colder than it is today. This means that Mars is farther from the habitable zone, will also be colder. So for liquid water to exist on Mars, the climate of Mars must have changed in some way. Make it warm enough. Although the scientific community is unsure of the cause, can only speculate. Mars, there has been some unexplained global ovulation event, but this speculation is not acceptable. This also led to the Martian environment, another explanation for something strange happening. We already know that the planet underwent a dramatic change in its axial tilt. It happens every 100,000 years, causes him to basically, like every once in a while, like Uranus today, fall over and stand up again. Right now, Mars' tilt is about 25 degrees, similar to Earth, but it can reach 70 degrees. This causes very dramatic seasonal changes. Since a year on Mars is longer than on Earth, each season can last up to 6 months. It can also go as low as 0. This means that sometimes Mars has no seasons at all. All of this has implications for Mars itself, had a drastic impact, especially its atmosphere or ice content. Depending on how sharply Mars is tilted, its atmospheric pressure will change. The amount of ice at the surface increases or decreases. 3.6 billion years ago, the atmosphere of Mars must have been much denser than it is today. He doesn't have enough atmospheric pressure today. It supports liquid water, so the only way he could own the ocean, there must be a stronger, dense atmosphere. Mars may have had active volcanoes back then. The atmosphere is probably mainly composed of carbon dioxide. It's like the Earth. So 3.6 billion years ago, Mars has a lot of ice. We have liquid water and a thick atmosphere. However, this is almost certainly not a class. Earth-like environment. The oceans may not be what they are on Earth. It's more like Mars today. Axial inclination in 100,000 years cycle. Move from within. The special conditions on Mars could lead to make some big changes. It's fascinating. In fact, in my opinion, this could be the most extraordinary period in the history of Mars, because a recent study shows that. This is around the time the Martian atmosphere collapsed. The polar ice caps are rapidly melting, forming a huge ice cover. The oceans don't need the greenhouse effect at all. This new theory not only eliminates, except for an unexplained warming, demand for events, and allow Mars, possessing liquid water at cold temperatures. It makes more sense in theory. At this time, Mars is in the Noah period of its history, and the borders of the Hesperian period. It may be experiencing a large number of asteroid impacts, and in the Hesperian period, he may have had massive volcanic activity and the formation of the Grand Canyon. So Mars 3.6 billion years ago, it's a volcanically active place. It has a thick atmosphere, although it may be very cold. This should limit the existence of liquid water. 100,000-year axial inclination cycle may still continue. This has important implications for its atmosphere. When the axial hydrogen on Mars is higher, the poles receive a lot of light, and the equator barely receives it. So at this time, the polar ice is released into the air as carbon dioxide gas. Some gas remains in the atmosphere. Some of them drift towards the equator, absorbed by the Martian regolith. When the axial inclination of Mars is as low as 0 degrees, the poles receive almost no light, and the equator is the hottest. So there was a change. The atmosphere was deposited on top of the regolith. It gets heated by the sun. This heat causes regolith release these gases. Eventually, they return to the poles and freeze. That's when the atmosphere collapses. It is worth noting that in all these processes, the polar regions never really get hot enough so that the water ice melts. It's just carbon dioxide. It's ice, so there's lots of free carbon dioxide waiting to return to the pole when the axis inclination decreases again. And that's exactly what the research found. Huge amounts of carbon dioxide return to the poles. It's cold enough, can be frozen again. Now, there is a layer of dioxygen about 800 meters thick on the water ice, carbon deposition. The water ice itself is about 4 kilometers away, covered on 2 polar ice caps. Because Mars is in a period of low axial inclination, they receive very little light. At the same time, atmospheric pressure is still strong enough to support liquid water. It's just that his carbon dioxide is used as ice, trapped at the pole. This is where the volcanic activity takes place. Mars at that time, more internal heat than today. These calories, usually, it's just slowly radiating to the surface and into space. It sometimes fuels volcanoes. But in the polar regions, half a mile of dry ice blocks the heat. Carbon dioxide is a greenhouse gas, very good at reflecting heat. So extremely, and it just stays there for a long time. Dioxygen that does not allow heat to escape, warming under carbon cover. This causes water dissolution of the polar ice caps start flowing. However, as he penetrated the driest layer, he freezes again because the polar regions are very cold. At this time, all fluids, it's trapped on carbon dioxide ice. It's surrounded by permafrost. The only place to go is underground. So the result is huge rivers flowing out from the poles. Through Mars, it's covered in ice. The water flows until it reaches warmer areas. There will be huge lakes and oceans integrated there. Because it's still very cold, ice sheets formed on top of these oceans, causing the surface of Mars. Giant ice-covered lakes emerged. One such potential lake is in the Algier Basin. It's almost as big as the Mediterranean Sea. So Mars 3.6 billion years ago may not be as portrayed. Is a climate-friendly ocean planet. It's an icy planet. There are huge layers of water and carbon dioxide ice, covered with very long rivers and huge oceans. As the axis tilt continues to change, these rivers and oceans, increasing according to the tilt of Mars, minus, it's not just a very unique environment. And it explains a couple of things. I should clarify here. We're not sure if that's actually happening, but there is strong evidence to support this. First of all, this theory, eliminating an unsolved global warming problem on Mars, demand for events. If this hadn't happened, liquid water must exist on Mars. It requires an unusually warm atmosphere. No real explanation. How did this atmosphere form? Or how does he retain so many calories? With ice-covered rivers and oceans, we don't need global warming. And very cold Mars will still have everything we have today. Evidence of water seen. Secondly, an important requirement of this theory is that the huge river mentioned above, if this theory is true, the atmosphere of Mars falls on the poles and melted them, then these rivers must exist. They must have formed about 3.6 billion years ago. The evidence we see is there are a series of huge valleys around Mars, such as Argyll, Marua. The valleys of Laen and Usberg flow north. In Palo-Pidanus, its gatherings and the Valley of Cyrus flow from the south. They're all connected to the Algiers Basin. As I mentioned, there is a submarine, an ice-covered lake the size of the Mediterranean Sea, location of birth. These valleys are almost certainly made up of. It's made of water. All existed about 3.6 billion years ago. If they are filled with water, they will flow directly into the Algiers Basin. And this is the proof, the most likely evidence for the formation of ancient rivers. In fact, in this case, so much water is dumped into Algiers, so much so that it actually came out. Discharge excess water into surrounding lakes and rivers. Those who didn't arrive. The Aral River flows into the low-lying areas of the north. Explains the waterstone evidence there. So even though it hasn't been confirmed yet, these favorable evidence, it is shown that this is what happened on Mars. But more testing is needed. Certainly, there are other theories that could explain this. For example, if we find out 3.6 billion years ago, there is a global warming process on Mars, then the previous theory is completely unnecessary. If this is true, then once the water reaches the equator, he eventually became warm enough, can evaporate, and it acts like carbon dioxide. Some of the water vapor returns to the poles, completed the water cycle on Mars. However, if this were to happen, but he didn't last long. Because the atmosphere of Mars is stripped away by the sun, in each cycle, less and less carbon dioxide reaches the poles. This means more and more heat is lost. As a result, less and less water is being melted. Rivers and lakes are getting smaller. So the entire atmosphere collapses to the poles, leaving glaciers thousands of miles long. It's covered in ice, flows into larger ice. Cycles that cover the ocean probably only lasted about 100 million years, then stop completely. After that, the atmosphere of Mars has become too thin, unable to support liquid water, leaving rivers and oceans completely dry. So today, all the water marks on Mars traces have evolved this way. Unfortunately, Mars lacks a magnetic field and replenishes its atmosphere. This means he is doomed to lose his atmosphere. Mars' axial tilt is still changing dramatically today. The atmosphere still collapses every 100,000 years. When the tilt of Mars is low, huge amounts of carbon dioxide still deposited on the poles. This is also another very important aspect of this theory: strong evidence. Until today, still in modern times, it's just to a lesser extent, but carbon dioxide sinks. The deposits are nowhere near enough to melt polar ice calcium. Even a small amount of ice melts. Liquid water doesn't last very long either, because it will be on Mars, boiling in the thin atmosphere. So basically, once the sun starts to heat up, carbon dioxide still trapped in rocks will be released back into the atmosphere of Mars. If this release rate is fast enough, at a rate faster than the radiant glass atmosphere, then Mars could already be warming. And there's enough pressure to support liquid water. Then, just like before, the polar regions will begin to melt. The water will once again leave behind those ancient rivers and to get too hot in the sun before blowing away the Martian atmosphere and water content. Ancient Mars may have ended as we expected, totally different. He's not at all as warm as the Earth. Ocean planet. It was an ice age, after thousands of years of intense axial tilt changes. The intensity of the tilt causing a more severe atmospheric collapse to the poles. Melting the polar ice caps doesn't require global warming. Melting water has carved rivers across the surface of Mars, although they are covered in ice, not exposed to air at all. Eventually, the river discharges to the Algier Basin, a huge ocean like the Earth or the Northern Hemisphere. The size of these bodies of water, according to the tilt of the axis of Mars, drastic change, then slowly die with Mars. The cycle is getting weaker until it stopped completely about 100 million years later. Until today, the Martian atmospheric collapse cycle persists, but much weaker. This theory, although it will take some time to confirm, but the entire planet provides direct evidence. The ancient solar system is teeming with strange worlds, just as the Earth for 100 million years ago might have had rings and extra satellites like. Thanks for watching. Welcome to the channel to talk about the Mars in your heart.